In the 1930s, Wright had a major comeback. We saw it earlier with the Falling Water House, with the Johnson Wax building, and the Usonian houses where he designed project for affordable housing that would be able to be built in middle-class families. What about other housing projects at that time? You know, it was pretty big achievement, the Falling Water project, and what happened afterwards after such a major masterpiece?
Right. Well, we'll look now at the Hanna House, which is same principle as the Usonian houses, but this is for a somewhat well-to-do client, a professor at Stanford, so it's in Palo Alto. So here we are, the Hanna House, Palo Alto, California, 1937. Now, take a look at that. And we don't immediately notice that when we look in up here, see this kind of funny articulated edge to the bricks. And what's going on is that's not a right angle. That is a 120-degree angle. So these bricks are sort of making something funny going on here. And what that is this house, let's just jump ahead, does not have a rectilinear plan. It's we call it a trihex, triangle and hexagon. So remember we talked about he pours slab on grade. So he pours a slab, and he doesn't like the idea. There's no way he's ever going to make a basement. His basements have no business existing. Now we score into that slab this grid, and that now gives the contractor a guidelines to just build the thing, you know, along this grid. And so here is our fireplace. Kitchen, dining room, and then we've got actually this is the later version of it. And because as the kids grow up, they change some of the things. And then we've got a guest house, shop, car garage, all on this grid. So you can see the house deployed sort of into the landscape in this kind of flowing manner.
Without any columns in the interior, right, as we saw in the plan. That's correct.
Right. It's going to be using just these wood partitions. And this is another one where you got to make reservations a couple months in advance if you want to visit it. So it is quite a popular attraction. So here's our grid. We see triangles and hexagons integrated together. Now, let's take that grid, and it gives us a guideline for a line, and then another line. Now, we talked about Wright didn't like, wanted to destroy the box. So you are in a room and you come to the corner and you go this way. Here, there's no corner. You just keep flowing. So instead of 90 degrees, it's 180 degrees. And so this idea of continuous flow. And now, oops, now we got another, oh, that's good. That's another 120. Here's another 120. And now what happened? We got a 60, that's really ugly, a 60 degrees. We got really stuck in that corner. So we'll just cut that off and make that a broom closet. And so now you get a 60 degree, you can make it into two 120s. And so it's always flowing. The space is always flowing. There are no corners. There's no 90-degree corners or even 60-degree corners where you'll get stuck. You're always flowing. So here is, we come flowing around the fireplace. Here again we see these bricks are not at 90 degrees, and so it gives us these articulations. And then we see, here we are in the kitchen. Wright was notorious for tight kitchens. He didn't make great kitchens. The very early houses did, but those were staffed with servants. But here, poor Mrs. Hanna doesn't have a very extensive kitchen. But again, we see these bricks allowing this 120 flow. And then these 120s make these crystals, like giant quart crystals of 6-sided crystals. And it's a children's playroom. There are the toys, and the wall just flows in and out, in and out, in and out.
So what is holding the slab or the roof? Is it the mullion itself that's structural, or there's some other device?
There are places where, see where it's black.
Right.
Those are structural. Everything else can move. And in fact, when the kids grow up, everything gets changed, keeping the grid, but changing the rooms around. So there's a book that describes the transformation when, the kids have grown up and now we have a TV room and stuff like that, which you would not have had in 1937.
Well, the kitchen had a double height ceiling. No, it's very small in plan, but it's rather high in section.
And this is now before air conditioning, and it's not too bad in Palo Alto. It's not like Los Angeles, but it can get hot in the summer. So we've got vents that open up, and so the air rises up, and it's double roof, open, so that the air can flow out, or the air flows through here, and so the sun is baking this roof, but not baking the roof. It's baking this roof, but we're under this one, so that air flows here, and then air can come up and carry out. And then these walls are not stud walls. They're panel walls. Now, Wright develops these walls. Again, we've got the double walls, and we've got a panel joint, all milled, no plywood, but all board and batten. And then we have this joint here. And this is then used in every case. Variance, see, we've knocked off this little bump to get this condition, but all of these allowing the different joinery in our wall plan are variants on this guy. Now, the idea here is that this can be mass produced in this one type. The fact is that the mill that's milling that says, I can give you 6 different ones for the same price and them all the same. It's just not a hassle. But it's at least thinking in terms of mass production.
Sure.
So here is the original plan, and here's how it's altered after the kids grow up. And we see how it keeps the grid, but the walls are able to move within that grid. And just going by it, you probably wouldn't notice all this. It just looks like a brick suburban house. You have to look, oh my God, there are no right angles. So, should houses use right angles, or are other geometries also acceptable?
Well, we know that today there are a lot of experimentations with curved geometry, with organic shapes, and with very complex designs, which nowadays are possible because of the technology.
And what's the big
we have
problem?
Of those geometries.
How do you put furniture in there?
Exactly.
So there's a really big advantage to the right angle. You can get furniture in there. It's modular. It works. And so Wright's got a lot of custom furniture in here, and it doesn't move around too well. So that's.
Well, he could charge extra to design a custom-made furniture, right?
Right.
Or you can do like the Japanese houses where you don't have any furniture, so you just leave it as open as possible.
He even had hexagonal beds, and they said, okay, we're doing away with that, and they got a big double square bed.
I see. That's impressive. Well, quite interesting for this house is the actual section. The plan is very experimental and very unusual and surprising, but the section here, it's rather contradictory to have the kitchen, which is double height space. It's double the height of the living room, which we see right next to it, and also the bath, which is also double the height of the bedroom, right? So this is something quite unique, no?
But it provides natural ventilation. So.
It does, yes, and rather striking interior. But in terms of like served and serving space, you know, the main space, which as Khan would say is the most prominent and the most spatial, is here inverted, or the
Right.
double height space of Le Corbusier's
Right.
Unité d'Habitation or Citroën house, where he would make the living room higher or double height in relationship to the others. Here it's kind of inverted, so it looks like he didn't care that much about the proportion of space in section. He was much more interested in the plan in this case.
Well, as I said, when the last time I was in Palo Alto, I had failed to make a reservation 3 months in advance. So this one I haven't visited. I've visited most of Wright's work, but this one I've got to know when I'm going to a conference at Stanford 3 months in advance and make a reservation.
Interestingly, he continues to surprise, no, because the Hannah House is only a couple of years after the Falling Water House. So
Yeah.
you would think that he would continue the design or the style of the Falling Water House, knowing that it's so successful into other projects. While here he's able to completely reinvent himself and come up with something totally different. So in the last 3 projects that we saw, the Johnson Wax, Falling Water, and this one, all 3 of them are designed with completely different geometry.
Well, he would say that's responsiveness to the landscape. You know, he's very doesn't want to be formulaic. We're going to find some patterns, but you know, you want to be organically responsive to each landscape and climate, etc.
And experimental. It looks like he never got bored with his design, no, because every every project was so different.
Right. Where do we get to his last projects?
Oh yes,
It's called the Flying Saucer Stage.
We'll take a look at it in a moment.
So next we have coming up, we'll talk about Taliesin East and West. So we've mentioned Taliesin East. We'll look at it a little bit more, and then Taliesin West.